start. Welcome to the next session. For your lunch, it's good. You all have food, full food today. So today we will be sleepy, yeah. Okay, let's start for the next session. This session. I will lead this session. Before I start, I have two information for you. The first is I would like to give you some little bit tutorials to access the material in the summer course that you can access, download, and then you can use in the futures. Yeah. Before it, I would like to introduce myself. My name is Martha Setiawan. I am from the Faculty of Mathematics and Natural Science, Universitas Gadjah Mada. I'm from Computer Science and Electronic departments. My research major is actually in cloud and grid technology. So today I will lead you to discuss about the cryptography and in computation. So it will be hopefully it'll be nice, it will be interesting. And before it, for you, for all the participants to access the materials, we already establishing the course in the ours MOOC platform. You can access directly to logs.ugm.ac.id. Okay. The participants that came from another university of another country, you can register first. This register, you can use your email address, and then after you register, of course, you can you have a verification to your emails, and then you verify the link, and then after that you can search the course. Yeah, because I have the access, so I will use my account first. Okay. Okay, and then the password. Okay, after that you can search the course using the keywords coding theory. Yeah, you can use this one. Just search in here, which coding theories. Search, and then you will have the long name of this course. Summer course, UGM summer course on coding theory and cryptography. Just click the course, and then you need to enroll. Just click the enrollment buttons, and then you will ask the enrollment code. The enrollment code for this course is SC2019. Just enter the numbers and then the letters, and then yes, you in to the course. After that, yeah, just serve the facilities, and then you can find day per day activities and materials. Unfortunately, not all the speaker has delivered the material to me, so I will update it as soon as possible. So please be patient, but I will ensure that all the material will be accessible for you. Okay. Okay, that's it. That's it for the course. And then, okay, any question about the facilities? The second facilities is we also recorded all the course of the speakers. So I will give you later the link to the video. Hopefully, if you not, for example, you follow the presentation, but unfortunately you not catch the talk about the materials, so you can repeat by seeing the videos. Later we will inform you after we finish all the technical things about the video. And yeah, you know, not only just upload to the YouTube, of course. Yeah, you need to do something. Okay. Okay, that's it. No question? Okay, nice. No question. Okay, so I would like to start this session with games. I will not make this summer course not very serious. I think the last two sessions very serious. I think, and I see your face is very, have fun in quote. So let's start our discussion with some some experience using the games. Later I will present my presentation first. Okay. So if you want to know about my activity, you can access my website. I have two websites. The first is my laboratory website, SK2019, and then my research on the cloud.wg.ugm.ac.id. You can directly contact me. So just send the email to me, margani@ugm.ac.id. I'm very happy to discuss with you in the future. Okay. So maybe if I got lost in your country, so I can contact you too. Because I like to get lost in some place. Okay. Okay. Actually, my experience in cryptography is same with you. I still learn. I still explore about more than in cryptography, especially because I must honest to you that actually I am the person that work on a lot of in the hardware actually. Build some architecture for big data processing, make some architecture for, currently we deal with the blockchain technologies, something like that. So let's see, we will discuss the cryptography, not only just about the process of computation to solve the cryptography itself, but also what the demand on the infrastructures. So it will be very nice, it's very interesting because in the industry, for example, if I discuss with my friend from the industry, they always ask to me, Madani, can you give me some talent from your university that can fill the gap between the cryptography and the infrastructure? Okay, it's me. So now that's, I just answered the question with that answer. So that's the problem. The next problem is about one of the infrastructure issues is also computation based on the operating system itself. So sometimes we try to process some cryptography processing, for example, but we doesn't aware about the need of the computation resources. So that's the big problem. So sometimes we will judge the cryptography algorithm, for example. It's wrong. It's very bad, for example. But I'm not going to optimize that if we know about the resources, which is operating system, hardware, and etc. So that's the issue that we will discuss today. And okay, so I only have 3 things that we discuss about 1.5 years, 1.5 hours, sorry. And then we will discuss about cryptography and computation, which direction we will go to the futures. And then I will go to the big data challenge that also makes some demand on the cryptography processing, and then case and discussion. So I would like to be, I will ask you to let me to invite you to join with this and a lot of activities today. Okay. Okay. Let's start the game. So sorry. We'll go to the games. Actually, for me, cryptography is like games. You agree or not? No. What do you think? Yeah, to be lawful with the cryptography, you must think very fun through in the cryptography. So when I start learning cryptography, I just think cryptography is just a matter of games. Yeah. Of course, the very serious game and very games, something like that. Okay. So what game that we will do today? Yeah. Okay. I will give you some. I will give blank papers, and then I will decide. For example, one line of the participant is one group, from the first line until the end of the line. And also in this case, okay. I believe you and your friend behind you is not. You have handshake and ask the name. No. Okay, so it is very nice. It will be the good activity to know each others, and then make connection in Facebook, follow the Instagram, and so on and so on. Okay. So what your tasks? Not tasks actually. What your games? The first persons in this line will be the person that have the key, and then the key will be used to open the some box that will be delivered until the end of the persons. Okay. So the question is about I don't know. This is cryptography things or not, but actually this activity I also have when I have a workshop in Singapore about cryptography too. So I make it in here. So okay. So I will distribute this first before I give you some explanation. I'm sorry. You can distribute to that. Okay. Yeah, of course, towards the first line of your groups. Okay. Okay. Only one papers. Okay, one papers, and then bring your pen or your ballpoint to write some things. Okay. Okay. So this is the first question for the person that have paper today. The other is doesn't have any challenge. Yeah. The first challenge is I would like you to write one word, only one word. You know words consists of some alphabetic and alphanumeric something. Don't be too long. Okay? One word. Okay. And then in one word, I would like you to express your feelings today based on your current experience when you follow this station under this session and you have lunch and say in one word. Write them in the big letters. Okay? You can use the formal language. You can also use some, social media language using the emoticon or something. Please, like that. Okay? Don't show to your friend. Don't show to anybody. Okay? Okay. Is that? Okay, then. So your challenge today is your word is very secret. Because it's very secret, if anyone know your word, you will be distracted. You will get after this. Okay? So I would like you to do something with your papers. I don't know, maybe you will make a form of the airplane, or maybe you make some blocks or something that make sure that your word doesn't appear to anyone. Okay, just do it in 5 seconds. Okay. Don't be serious. Relax. Okay. Okay. Do the best techniques of origami or some things that make people cannot open the papers. Okay. That's your best effort. Okay. So the next challenge for another person, that one group with the first person is, I would like you to guess the word. To guess the word. Okay? Guess the word. I don't know. I cannot give you any clue, and you doesn't need to give any clue to anybody. Okay? Yeah, something like that. Okay? Okay? Just guess, and then we'll be like this one. I would like you to guess, for example, the first person. This is the answer, your name. Okay, Mr. Zaki. Maybe, for example, he guessed about from Mr. Neil. Okay, Mr. Neil say, for example, I guess your word is fun, for example. So Mr. Zaki will guess what is the Mr. Neil words, and then if you have same word, you need only to write in the papers, in the blank form of the papers, for example, anything, the word that maybe appears in the word. It can be the first word, second word, or many words. If you doesn't have any idea, just leave blank. Just leave blank and then do it, okay? And then we do very fast. Only in 10 seconds, it should be very fast. Okay? Ready? Ready? Yeah, pass to another group. Okay, 3, 2, 1. Okay, pass to the second person.
They need to guess.
Up to. Only one characters. One characters of the word that we need to guess. Okay? Sorry, I say word. One characters. One characters. Only one characters. Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, And 1, and stop. Okay, stop, please stop. Okay, stop. Okay, stop. I would like you to raise your hand and show me your papers, which part of you that have you finished point. Okay, okay. Hang on first. Wow, it's nice. Okay, so I would like you to ask the first person. Can you pick up the papers? Don't open, yeah? Don't open. Okay. Okay. Okay, just give it. Okay. So I would like to ask first the second line person and then and another person. How you guess the word? How you guess the word? Oh, okay. So, okay, it's nice. Okay, good cryptography algorithms. Okay, nice. What else? What do you do? Anyone? Yeah, how to guess the word, and then you define the characters. Oh, explain. And then what else? Anyone? Oh, the frequencies. Okay, it's nice. And then?
Guess.
Just guess. Okay. Okay. Good one. Okay. Maybe that's random for something. What else? Anyone? Do you have any idea? Oh, okay. Yeah. Okay, and then? Okay, that's it. Enough. Okay. Next, I would like to ask the creator of the words. Okay, the creator of the words. Mr. Neil, what's your word? Is it close with your words? No, not John Owen first. No? No. Okay. And then, what's yours?
At least there is one.
Only one word.
One letter.
One letter to get matched with the word. Okay. With you? Sorry. 2 letters. One letter. One word. And 1 letters. 1 letters. Oh, 3 letters. Oh, nice. Okay. And 4. Okay. Only 1. Okay, 1. Okay. So we have a problem now. The first one is how to guess the word, and then we do need the time to proceed the computation processes. Then actually, the 2 kind of problem is occurred in cryptography today. Is correct or not? Yeah, in some case yes, in some case yeah. Let's discuss something like that. Okay, so let's open your word. Open your word, and then ask Mr. Zaki, what your guess? This is random, only random. No, the word. No idea. Who is the person in the endpoint? This line, the first line? Oh, you? Oh yeah, okay. No idea. Second line, any idea? No. Happy. What do you think? Oh, it's correct. Wow. You respond to the algorithm of cryptography. This one? This one, the endpoint? No idea. Yes? Yes. Everyone in line here. Do you have any?
Can you tell me how many correct the you already mentioned
Yeah.
but I cannot follow. Something that's correct, right?
Okay.
So I guess it maybe it's just your first name.
Oh yeah. First name. Okay. What's your one? Confused. So my first name is confused. Sorry. Anyone can guess the word? Lucky. Yeah. Okay. Okay. This one? Anyone can guess? No idea. No idea? I have no idea. What's your word? Excited. Is that? 24. Okay, that's it. So I think the cryptography, one of the philosophy of cryptography, not only just how we we do the method of cryptography. But the problem is in the communication problem, I think, yeah. So that make our country make a war or something. Okay? So that's the problem. Okay. 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 So that's the first one. The part number 0 of my presentation. Hopefully, the current activity can give you some insight about what we discussed today. We not only just about how to deliver the message, how to deliver the information, deliver the data, but also we deal about the time and then also the approach that we can use for it. Actually, I not mentioned anything about you can do some cheating things. Yeah. For example, I deliver the papers and then I give you some signal. Or maybe you can use the WhatsApp. I think it's clear enough for you to solve the problem. Something like that. Okay. But that's okay. So I would like to go to the first one. So I will go to the computation perspective first. Whatever we do in the processing, especially in the computation processing, for example, not only cryptography, we always have a problem in this kind of the method. The first is do some processing with this sequence process or do the process with the parallel processing. The same, if we deliver some message in the sequence, it's mean sequence. So we must follow the orders. We must follow some very rigid rules to to deliver the message. Yeah, we do in the last activities. We do something like that in sequence. So of course we have a challenge in there. The challenge occurs when we not only just the data itself need to be touched by some things that make secure, for example, but also we must think about how the person can how the sequence can deliver the data into the destination, for example. Like I say, when I ask you to do to make some form of the papers, actually you doesn't need to make some very rigid architecture or something, but just make sure that the word is not open up, but actually you can do something to analyze what of the kind of the word that or letter that appears in the papers. So that's the things actually we can do. So, but unfortunately, in the sequence processing, we need to deal with the time, because when we have this sequence, what happened? Yeah, we need to follow the order, and the order is always deal with the time. We have a lot of time consuming here. So that's the problem in the computation actually. How we can deal with the cryptography if we do with the sequence things, but in the computation time it is appropriate. So that's the problem. The second problem is parallel processing. Yeah, this is occurs to try to solve the current problem in the sequence processing. We do the parallel computation or parallel processing, but the expectation is to decrease the time of computation, but in the another side we have new problems. How to ensure the data that you distribute in the parallel way is correct, is still in the form of the originality and so on. So that's the problem. So we now have we have now one option to deliver the data. Let's say the last speaker talk about the encryption processing, how to deliver the cheaper text and so on. So how we distribute that one in the sequencing, the sequence, and in the parallel links. So that will be discussed today. So at least in the years, it is very traditional architecture that we can, let's say, that instruction in the sequence processing will be delivered each by each. My word is each by each, step by step orders. So yeah, of course, if we do that two things, the instruction need to be accepted, and then, like say in the network things, we need to have a handshake to understand about the message, and then we accept the message, we do some acknowledgement, and then we deliver the process. in the parallel processing, we can have actually the behavior is like in the sequence, but we do in the same times. Do it at the same time. Why? Because we have a channel, we have parallel channels, or we have a parallel distribution to distribute the things. For example, when I do this experience again, for example, when I have these papers, how if I ask Mr. Miller, for example, to slicing the papers, each by each letters, and then distribute randomize, and then in the end of the line, they guess the word. It's more easy or not? In this case, it's more easy because you need to only like passing the letters. Yeah. But how about the computation processes? Sometimes it will be fast, but sometimes not always fast. Especially when you will be like in the middle of the node, but you act like as a hacker, for example. Oh, this is good letters. I think I will keep it first. Okay. And then I will replicate this first. And then I will distribute again, and so on. And then in the end of the line, the people in the beginning only have 5 words. In there we have 10 words that have many duplication. So that's the problems in the distribution. So in the parallel processing. So that will be a challenge for us to discuss about it, to think about it, and then how do we and then in my opinions, as a cryptographist, for example, you are in the future will be the expert on the cryptography, for example. Not only think about the cryptography itself, but how we make sure that cryptography will work on the software environment that deal with the problems, because that's the real problems cases. And then we also have a new approach. We have a 2 approach. The first approach is based on the architecture. The second is about how we do it. The first approach is using the conventionals, using the digital bits, 0, 1, and so on. That's will be we need to deliver it. Last night I see discovery channels, how the colibri bird, the colibri bird, to communicate with another colibri bird. It's using spelling or sound of the mouth of the colibris. And the scientists say that it's like a computer network. They send 0101 bit to understand about the message of the another birds and so on. And then it's used for colibri to recognize which tree that already has been used by the another colibri bird, and then the another colibri will say, okay, this is good tree, because the colibri is like to smashing the mud to the tree, something like that. So it would be like we have a digital sign in that data, and then we use the digital sign to verify about the message. But today, I think we will discuss another speakers, about the quantum. The quantum gives the opportunity to us to not only process the data based on the digital bits, but also using the quantum bits. So it's mean actually for me, it's just how to think about quantum is like the same way we talk about the sequence and distribution and parallel processing. We reduce a lot of digital bits in the same time. So it will be very interesting. So we will be discussed later. So you can see in here, conventional and quantum have the same problem actually. How we can solve the problem in the to increase the algorithm performance, especially in the performance of the computation processes. So that's why in the quantum cryptography or the quantum processes, they say that we try to extremely high speed algorithms to process some data. So that's the case. So this is the direction. We will discuss in the end of in the entire of this summer course. I think a lot of point of view that we can use. But at least we know about it. Okay, the next is this is the quantum. I would like to go to the quantum computing a little bit, because I would like to give you some direction about how the computation need to aware about it. Because in the sequence processing, for example, we can let the processing in the single node of computer, for example. In the parallel computation on the quantum computing, we need not only a single computer, yeah, but we need, for example, because the parallel itself and the quantum itself can use a lot of we can implement a lot of processes at the same time. So it means in the computations architecture or infrastructure, we also need a lot of infrastructure to support it. Just like say, if I want to distribute the data with high speed, extremely high speed algorithms to deliver the words, it means I must ensure all of the nodes that are involved in the distribution also have the same performance. Let's say Pak Anil is high speed writing for the word, but unfortunately Pak Zaki, yeah, it's very, one word in 1 minute and so on and so on. So it will be disaster. So that's the issue. Yeah. So that's why it will be very, very challenging. But only not just as limited as that when we discuss about the quantum, because we will deal about three-dimensional particle state and so on. I will not go into that because it will be another material to discuss about it. Yeah. So this is also has been discussed in the previous lectures about the cryptography. We have asymmetric key, we have asymmetric key, and then we have a classical cryptography approach, and then the modern approach. Yeah? Using the transposition cheaper, substitution cheaper, string cheaper, and block cheaper. Myself is very interested with the block cheapers today. So will be very even this is a different approach, but actually have the same issue in the computations. So as researcher, for example, we have a question today. How if we have a lot of methods for doing some cryptography processing, for example, but we only have one or common environment to do the computation? Will be nice. If not, we will have a problem when, for example, when we do some classical cryptography, we have our own environment. When we do the modern cryptography, we also need another environment. So it will be, something that not good enough for us. So that will be the challenge. So this is the cryptography tree that we need to deal with the computation. In the computations, we need to also have attention in the purpose of the computation itself. Not only just cryptography itself, but cryptography for what? So that it means we need to know about we need to define clearly what the purpose of the cryptography. For example, to support a voting process, for example. And then how about a contracts, for example, and then ticket, for example, digital signatures, and maybe for other things like cryptocurrency things and so on. So it will be different with purposes. Because when we have a purposes, the cryptography algorithm will be just to support this purposes, and of course the computation will need to be to follow the purpose. Something like this one. You join the summer course today. What's your purpose? Yeah, summer course. So we need to have a summer vacation to Jakarta. Something like that. Okay? For us, a lecture is very nice, very happy to have the summer course because we can run away from the faculty. So something like that. Same the summer. Okay? So that's the problem. So when we have a purpose. So how we do the things? Because my purpose is to have fun in the summer course, so I not deliver this lecture in the serious way. It should be fun. That's my cryptography algorithm to this. And the infrastructure. So that's the problem with infrastructure. So the infrastructure we need to have that supporting for the computation and so on. Same, yeah. So if we for example, I have the two projects for example. One in the cryptography to gain the forest fire in Indonesia, and then we also have a project in the blockchain technology for healthcare, for example, for medical records and so on. It's very different perspective, different purposes, and then in the end, the algorithm of cryptography and then the computation method and also the infrastructure is very different in different methods. So that's the challenge. Yeah. So the next question is for you as a future cryptography expert, for example, you cannot just only have a lot of gun and then use the gun for all anything purposes, for shutting down the predators, to kill the alien or something else. But you need a specific gun, yeah, to be, maybe to join the alligator or something like that, okay? So that would be nice. So cryptography would be that one, okay? In that case, and I think we have a lot of problem, for example, in Indonesia or maybe in Southeast Asia or something else that can be solved by this approach to this one. Okay, so that's why in the down of the tree, in the root of the tree, we have number theory, algebraic geometry, physics, quantum mechanics, computation, complexity, and the information theory. So when we learn about cryptography, I think the subset of this knowledge we need to have also, and then we have a wide spectrum to see about the cryptography, not only just cryptography itself. Yeah, it's the subject. Okay, so that's will be the nice one. So this is the type of cryptography. Yeah, we have using the RSA encryption. I think you already, I think it's learned in your college, for example. We also have lattice-based cryptography. I know it will be explained in the special speakers in the summer course. Define Hartman key exchange, code-based cryptography, elliptic cryptography, and multivariate cryptography. So this is the current approach that exists around the another approach that we can learn in the methods of we learn about the cryptography. So the next question is about this one. So how we deal with the cryptography tools when we know about the purpose, the computation needs, and the method itself? How we deal with it? How we place the cryptography in the right positions that make sure that we can deliver some good approach to the cryptography itself. Yeah. Okay. So meanwhile, when we try to answer that question in the near of us, we accuse a new issue, especially actually this is not only the one of the issue, but a lot of issues in there. So I will let you for this one in here. When we think about, for example, build some cryptocurrencies algorithms, for example, this is using the blockchain technology, for example. We're not only just using the cryptography, but we need to learn about the P2P networks itself, and then we also use the some game theory to combine and then bring a new approach on the cryptography, for example. Yeah, so that's the things. So the challenge for us, for you, for me, how we deal also about the multidisciplinary research, multidisciplinary approach, and to discuss about it. Let me share with you my current project, for example. Today, I will try to develop some cryptography algorithms using the update networks fly. I call it. It doesn't have any names, but you know the bet. Yeah, not the Batman, but the bat. Yeah, have a unique behaviors when he, for example, when the animals are out from the cave and then enter the cave again and so on. And why they always fly in the groups, never walk alone. We never walk alone. That's different. Okay. Okay, something like that. Why? And make me very curious. Why is that? And very effective. You know, bat is one of the bird, I don't know, bird or something. It's one of the animals that have very efficient to divine where that bird will go and then came home again. And never alone, always good. So I think it's quite good. And then we try to make some video in one of the caves in Jakarta, and then try to make some computation to have a model where he fly, and then until maybe, for example, he go from about 3 in the tree in this time, and then we go to the cave maybe in the 6 and so on. So we try to record, and then we define a pattern, and after that we define the model of the pattern, and then the pattern we observe, and then we invent the mathematics way, and then we try to build as the algorithms, as cryptography. It works? No, until today. But very interesting is it's good enough for deliver the message in very extreme performance when we deal with the big data. So very specific for big data, not for the small data or something else. So that's very interesting. So that's why we need to discuss about it, to think about the idea. So that's when we try to discuss it, we discuss about this issue, we will have a lot of insight to involve not only just cryptography itself, but computation will be involved in there, and then we have new ideas, new directions. That's good enough. Okay, so I would like to go to the part number 2. I will discuss with you the cryptography based on the purpose. I will give you some example on the big data, in the big data. So I think we have this architectures. The big data consists of several layers that process the data in the very massive way and then very extreme way actually. Try to capture the data from the source, from the IoT and so on, deliver the data through the connectivity using the internet, for example, and then keep the data in the data storage, the big data storage. But unfortunately, it's not only just in that case. The big data will be processed in the environment of big data engines, big data processing, and then will be served for the data analytics and visualizations. So the question is, where is the cryptography in this architectures? How if I say it's everywhere? We need the cryptography in the source of data, in the Internet of Things, for example. We need the cryptography to ensure the data that from the IoT go to the storage, which is in the network itself. And every layers with cryptography. For what for? To make a guarantee that the data that we process in the big data, for example, is secure, have the assurance, no one still in the middle of the transactions, no one manipulate, and then another things. Yeah. So that's the issue. So I think this point of view we can use in another case in the cryptography, and then when we want to solve some things, we want to solve some things. Let's say, anyone have a Facebook account? How much that have Facebook? All of you. Okay, so you are not the cryptography people, because mostly the person that in the cryptography will be the that doesn't have any account with social media. Yeah, we don't like you. Cryptography is always have a membership of anonymous group or something. No, I don't. Okay, so in your Facebook, do you publish your date of birth? No one? Who's published the date of birth? Only one? Only two? Or three? Four? Okay. You are happy people that always have a greeting from the Facebook when you have anniversary. Your friend, your family will forget your date, but Facebook always remember. So, let's say, what do you think? We discussed about it. How about date of birth? It's very confidential or not, actually. Anyone in here use the password of your email, for example, use 1 or 2 characters of your date of birth. For example, Mardan, and then Mardan is 08, for example. 08 represents my month of date of birth, for example. Anyone? Any? Yeah? Okay. Yeah, in this class we have 1 person. Can you imagine if I have 1 million people and have same, for example, 1% to that one, so I can build my accelerated algorithm to generate the passwords. Something like that. Anyone in the tweet output in your Facebook, you have information about your siblings or your your parents, your anyone, and very very comprehensive until your grandma, grandma, and something else. Anyone? Okay. It's also related. It is very confidential. It's confidential. That's very important, sir. If I have the three, it's me. Yeah, I have from one of the big, I don't know, something else. But sometimes when we, this is the good, not the good news, but this is the good discussion. Let's say, maybe I give you some. Last month, I have experience to invite the police in our province to be the analyst for some crime that use the social media that use your relative relation to do some illegal action, some illegal somethings, something like that. So it's really nice when we found that case. Okay, we need the cryptography to make sure that your relation is very good. So I recommend you that if you have any relation, even that's your sibling, your father, your mother, just make it complicated. Okay, complicated. It will be secure for you. Okay, so that's it. So that's the issue for this big data. So I think when we deal with this, the challenge of cryptography not only in the cryptography itself, but all of the aspect of our life will be need the cryptography. You also has updated your status today in Twitter that you in years. Okay, good enough. So your vacation will be nice trip. Because if you show your status, you're okay. Yeah, you will have a lot of message. Hey, don't forget to bring something from Jogja. But it's okay. I recommend you to give a lot of accessories and food from Jogja back to your country. Okay. So this is the problems. The problem in the purpose of the cryptography in the big data, for example, is how we ensure the active device to secure the active device or Internet of Things. The third part, I will give you some case, and then I would like to discuss with you. This is my real project that I have Internet of Things for disaster. I plan some IoT device in the server regions in Central Java, and data transmit to me directly to my data center in my campus. So the problem is now, I only have my data in every 3 minutes. I order my IoT to send to me every half minute. So that's the problem. So sometimes I have my data from the sensor, but unfortunately, the data is very strange. Something not really like behavior of the IoT itself. So I confused. This is something that really happened because of the problem from the sensor itself, or maybe there are any intercept in the middle of the data, for example. Something like that. So that's the problem. And then about the data collection, this is also the problem. Can you imagine that one? For example, in this room, we have a CCTV, and we capture every minute, frame by frame. Yeah? And then, for example, I'm not afraid it's happened in this class. For example, one of the participants complained to the committee, I'm sorry, I lost my gadget, for example. And then how we found the suspect. And then we go to the frame analytics of the CCTV. Every minute we try to break down and then see about the pictures. And then what happened? If I have some skills to add your pictures and then add to the frame, and then in that time you appears in the screen, maybe you can be the suspects, even you're not in this room, for example. Something like that, yeah. So it's really very matters how we secure the data collection process using the cryptography. And then the response Also the next one. Of course, I know that you already know about the concept of the smart city, smart home, and smart transportation, and etc. Yeah. So it's also nice to have the security in it, and then the toll system. In the infrastructure itself, this now become the problem too. Maybe tomorrow I have a colleague, his name is Dr. Vicky Ferdiana. We will discuss about the cryptography in the cloud. So if we build up the cloud, the cryptography doesn't need any physical resources. So how to ensure that our data is not, processed in the process itself is virtual. The result itself is virtual. So how we deal about to answer the resources, and then platform, software itself, and then we do the data management, and then in the end is the visualization. That's really the latest challenge. In the another perspective, we have this definition when big data have a lot of feed that make we should deal about it. We have a volume, variety, velocity, and value. Even another definition, they also have 8 feet. IEEE itself have 43 feet. So a lot of definition in there. So one of my curiosity is about the veracity and the velocity that deal with the security and also the assurance about the data itself. So that will be the challenge. Okay. So this is the big data process. In the big data process, for example, we have a lot of source of data. They can be from streaming data, text data, application data, and the social network that I give you some examples. And then all the data will be captured in the one times. So it's meant because we need to capture the data in the one time. We need not only just sequence processing but also the parallel processing. So that's why it's characteristic. Most of the implementation is using the faster environments and also using some high performance computer to do the processes. In the big data platform capabilities itself, we also deal with the sum workflow that's known as the big data processing workflow. Then in the workflow itself, for example, if I have 1 gigabyte data and then I distribute in the, for example, in my lab, I have a 9 node of cluster computers, for example, I need to break down the 9 node of the computation processes. So I need to have assurance that when I break down my processings, it will be processed and then returned back to me in the appropriate sequence, for example. So that's the problem. So we need a cryptography. So that's why it's very challenging. If I only let the process using my big data processing, for example, algorithms, yeah, it will not fit with the purpose of our discussion in the first discussion. And then after that, we need to have analytics, yeah, using the cognitive analytics to support the cognitive analytics, exploration discovery, and all this analytics will be useful for many purposes in industry. For example, for automated process, case management, analytics, application, web services, and also another solution. So that's the challenge. Okay, before we go to the simple case, I will do the second case. Okay, anyone still have my blank papers? Okay, new papers. Pick one. Okay. Please distribute. Okay, so you already have experience in the first game. So the next games will be actually the same, but we do a different approach. Okay. So in the first game, you try to guess one word that represent your experience in the summer course today. The second game will be slightly different. So I would like to write this one. I would like you to, the first person is to imagine one place in the world that when you hear about cryptography, it will be reflect one city in the world. For example, cryptography is close with the, for example, London, for example. I don't know. Yeah, it is on your own experience, okay? Up to you. just take one of the city in the world that made for you is close with the cryptography. I'll give you 1 hour to think about it. Please. Okay? Anything, random, okay? One city. For security reason, select one city that have only one word. Don't just Manchester City. Oh no, that's okay. London, for example. New York, no. New York is on two words. Something like that, okay? So, Mumbai, for example. Bangalore, for example. Tokyo, something else, okay? It's up to you. Okay. Is that? Now, then after you finish the first city, I would like you to give your papers in open